What's up, guys? Welcome to another weekly banger episode, tutoring video on Chemistry Uncovered. And I hope that wherever you guys are on this world, wherever you guys are watching this, that this video finds you well and you guys can learn more about chemistry through these videos, and because that's Chemistry Uncovered's ultimate mission, right? And without further ado, this video is about periodic trends, right? Now, before we start, I think it's important to notice why chemistry is important in this world. So I have a really fun equation for you guys. You guys might have heard of this equation, photosynthesis. Essentially what it is that carbon dioxide is trapped from the air. Like let's say there's a plant, right? Let's say this is a plant. Carbon dioxide, and this is the sun, right? Carbon dioxide is trapped from the air, it goes into the plant, and then water from the soil, let's say this is water from the soil goes into the plant too, and it creates glucose. It creates glucose, and I'm gonna make a glucose molecule for you. Let's say so this is an atom, right? And then let's say you connect these atoms together, just like this. Like this is glucose, right? So when you have that sun and you put it into that plant, and when you have that water and you put into the plant, it creates glucose, right? Now, this is not the actual real representation of what glucose is. I just made this on the spot, but you get the point. It creates glucose, and what glucose does is that it helps give the plants better energy and for healthy plant growth and make a better ecosystem for this world, right? Now, without further ado, you might be asking, what are the periodic trends? What are the important periodic trends we have to remember? We have to remember atomic radius, ionization energy, electronegativity, and electron affinity, right? To start off, what is atomic radius? Atomic radius, just like in geometry when you guys learn about radius or something, or if you guys haven't learned geometry, this is the perfect place to learn about what radius is and chemistry. So it's like killing two birds with one stone, right? So atomic radius it determines how big an atom is, and also it's the distance from the nucleus, the center, to the valence orbital of the atom, which is the exterior. Just like how a radius in a circle is the distance from the center to the exterior, this is the distance from the nucleus to the valence orbital, right? And so before we talk about atomic radius, it's important to talk about effective nuclear charge, which is also known as ZEFF, right? Essentially, the effective nuclear charge is calculating how much charge the proton has with the valence electrons. So it subtracts the core electrons, the electron shielding the attraction force between the attraction force between the protons and the electrons. There's like shielding electrons right here, right? So it calculates the amount of shielding electrons and then how much charge after that there is between the proton and the electron. So the more effective nuclear charge means there's more protons and there's more electrons with the same amount of core electrons. That means the effective nuclear charge is greater and they attract with greater force, right? And if they attract with greater force, then the atomic radius is smaller. And so that's why for the trends, when you go across a period, when the atomic radius decreases because the effective nuclear charge increases due to the same amount of core electrons, because it's the same energy level, but more protons and more electrons, which makes the charge attraction force greater, just like positive and negative, right? And as you go down the group, the atomic radius increases because the amount of energy levels increases. So that's kind of straightforward. Second off, ionization energy, right? Ionization energy, as you can probably depict from this diagram right here, is the energy required to release the most loosely bonded electron in an atom. Ionization energy is always endothermic because the system always has to gain energy, which is positive heat enthalpy. It has to gain energy in order for electron to be released, right? To kind of start off, talk about the ionization energy trends. As you go across a period, as we talked about, the effective nuclear charge increases due to the more charge between the proton and the electron. So that means the attraction force increases, and the ionization energy also increases because you need more energy to kind of like take this electron away because the attraction pole is greater. As you go down a group, the energy levels increases as we talked about, and so there's more shielding electrons, and it's easier to take the valence electrons out because there's less attraction force, and so you need less energy to release the most loosely bounded electron, right? And so it's kind of important to know that the atomic radius and ionization energy, they're all interwoven into each other, but there are exceptions such as stable shells. If you have a half stable shell, they're actually more stable than like a shell with like 4 electrons or something, like P3, P4. P3 is a half filled shell. P4 is a shell with two non-bonded electrons and one electron repulsion electron. And we're gonna talk about that in quantum chemistry. But essentially, if you have a stable shell, the ionization energy is always greater than one with electron repulsion. And so if you go back to the periodic table, that means that the P3, so N, would actually have a greater ionization energy than oxygen because of the stable shell, right? And so why do I teach periodic trends? Why do I teach photosynthesis? It's to make the world a better place. Pretend like this is the world. Our atom of the world is made up of a diverse group of people, a lot of different, perspectives, a lot of chemistry, and we have to kind of help people, foster their growth academically, intellectually, socially, physically, mentally, so that they can make the world a better place, and have more chemical reactions that hopefully make this world a better place. So stay tuned for next week's episode of part 2 of periodic trends, where we're going to be talking about electronegativity and electron affinity. So stay tuned. Thank you so much for watching. It's been your boy Chemistry Uncovered. Peace out.